I am particularly impressed when an account takes a commendable leap forward by resourcefully and ideally successfully applying, in their novel context, a going digital innovation from a separate infrastructure domain. As you may know, I believe that our accelerating work to provide structural and functional digital twins for the world's communication cell towers is setting the stage for expansion of this approach to all infrastructure asset types. Hence, my hearty congratulations and Founders Honors recognition to Exo Inc. on behalf of Midwestern energy utility Evergy for proving out, under emergency circumstances, a breakthrough which deserves to become mainstream practice to sustain and improve electric grid resilience. During the pandemic, Evergy's Clinton-Stillwell high-voltage line through central Missouri suffered damage in a lingering flood. The world's electric transmission grid structure, or structure number 58, suffered deflection and then remained inundated. But it was the only source of grid power to multiple COVID-crowded hospitals in the region at the time, where patients would have been at significant risk, and as Exo put it, it would have been national news for this line to go dark. Conventional response, even in these acute circumstances, would have entailed waiting weeks for the floodwaters to eventually subside, during which the structure would have been on the verge of failure, before a survey crew could get on site to make the necessary accurate measurements of the tower's structural damage required to engineer a stabilization solution. And even then, the constraint that the line had to remain energized constantly would have prohibited climbing to its upper areas to perform an adequate survey. Exo saved the day in this case by innovatively adapting and succeeding with the digital twin solution that we have honed for cell towers. In this case, a flat-bottomed airboat reached the flooded site to launch a drone, which captured the needed overlapping imagery for our iTwin capture software to solve for a reality mesh 3D engineering model of the existing conditions of contorted structure 58 and its neighboring towers and connecting conductor. PLS-CAD and PLS-Tower could then be applied to work out a stabilizing structural solution, which, with matting for crane access, was able to be implemented in just 3 days. The world's electric transmission grid structures are largely beyond their design lifetimes, and the risk to resilience of our economies and to life safety under increasing perils such as climate extremes, as in this case, make digital twins of the physical grid ever more valuable and demonstrably feasible thanks to Exo and Evergy showing the way through their engineering breakthrough and through this Going Digital Award submission to share it. Congratulations.